So, rationalizing the denominator, what do we have to do with it?
Times it by the reciprocal.
The conjugate. Close enough. Reciprocal is when you flip it over. So, we use the conjugate where we switch the sign. The top, you would just distribute the 7 in to get 35 minus 7 square roots of 3. Bottom we FOIL, but again, the middles are going to cancel out, so we just have to do the first, 5 and 5, which is 25. And the last, which would be a minus 3, since 1 is plus and 1 is minus. Which ends up being 22 then on the bottom. Now, we would look from here to reduce it. But at this point, there's nothing that would break down that we could reduce, so that's as far as we can go. Questions with this? So, getting into polynomials today. Polynomial is a single term or the sum of two or more terms containing variables with positive whole number exponents in the numerator. So, this would be an example of a polynomial. Key thing is the exponents have to be positive whole numbers. We can't have negatives and we can't have fractions with them. And I believe this is the typo. This is supposed to be to the third. Notice how we also write them in descending order. So we have to do the third, then squared, then just the x, then the constant. So it's always the biggest exponent and then working its way down. So like this one has 4 terms, so they're separated by pluses or subtraction. So this plus separates it from this term, which separates from this term, which separates from that one. We have certain names for however many terms are there, starting with the monomial, which is just a one term. So like the 7x to the third would be a single term, so it's a monomial. Binomial is when you have 2. So if it was, say, 13x minus 6, that's 2 terms, so binomial. Trinomial is when we have 3 terms. So like x squared plus 2x minus 3 would be a trinomial. 3 terms. What do we call a 4 term?
Quadnomial.
Close. It's actually just after 3 they just go back to polynomials.
Oh.
Sorry, that was kind of a trick question.
Wait, so just call it polynomial?
Yeah, so outside of those 3 it's just polynomial. And technically those are polynomials too, they just have specific ones because those are the ones we work with the most. So, we have the official definition here of degree. So the degree of a ax raised to the n. So if a is not 0, so we can't have 0 for the coefficient out front, the leading coefficient. The degree of a non-zero constant is 0. The constant 0 has no defined degree. So, basically the degree is going to be whatever this exponent is up here is what it's saying. If there isn't an exponent, it's technically to the first, and if there is no variable, then it's degree 0. So if it's just the number, it's a constant, degree 0. Otherwise, it's going to be whatever the exponent is here. Now, the degree of a polynomial is going to be the greatest degree of its terms. So whichever your highest exponent is, that's going to be the degree of the polynomial. So like this one, if we go back here, we have x to the third, x squared, x, and then the constant. The biggest one of those is a 3, so this would be a 3rd degree. If the biggest was a 7, it'd be a 7th degree. So whatever that biggest exponent is. So, the official definition of a polynomial in X is an algebraic expression in the form of a sub n x to the n plus a sub n minus 1 x to the n minus 1, and so on and so forth. So, just know you're going to have coefficients, the numbers in front of the variables. You're going to have an x, typically with an exponent. Again, they have to be whole, positive real numbers as those exponents. They can't be fractional exponents, or they can't be negative exponents, or it's not a polynomial. So we can add and subtract polynomials just like we can any other set of variables and numbers. You're just going to do like terms together. So if it's x squareds, only the x squareds go together. If there's an x, only the x's go together. If there's a constant, only the constants go together. You're not going to mix and match. So if we have one like this, put like terms together, so we have a negative 9x to the third and a 13x to the third. What would that make?
4x to the third.
If we have 7x squareds and 2x squareds, we get? So it's positive, so plus 9x squared. Negative 5x and negative 8x make?
Negative 13x.
And 3 and negative 6? Negative 3. So just putting like terms together. Now, when we subtract, make sure you're subtracting this entire second one. So what I like to do is change this to a plus and then distribute that negative on through so that you know it's there and you don't forget about it. So then as we go through, now it's just like a plus equation. So we had 7x to the third and now minus 7x to the third, which may, or 2x to the third, sorry. So 5x to the third. Negative 8x minus 6x squared. We have a plus 9x and a plus 3x. A minus 6 and a minus 9. So, questions with these? Okay. So, next thing we're going into is multiplying them. We can multiply them as well. If we add, subtract them, we can of course multiply them. So, multiplying polynomials, you're going to multiply the coefficients and then add the exponents. So, multiply the numbers together, and then when you get to the variables, you'll just add the exponents together, and that's your new exponent. Now, when we're dealing with a monomial times anything, we're going to use the distributive property. We're going to take that monomial, take it times every term of that polynomial that it's timesing by. So if we have 3x to the fourth, we're going to take it times 2x to the third minus 7x plus 3. Again, we're going to distribute this to every term in there. So 3x to the fourth times 2x to the third. 3 and 2 will make
6.
x to the fourth and x to the third.
X to the 7.
There we go. So 3x to the fourth times the negative 7x.
Negative 21 x to the 5th.
And 3x to the fourth times 3.
Plus 9x. Wait, but it's not even x to the 6th? No.
No, because there wasn't an x squared. So, any questions with this one? So, when we start getting into binomials and bigger, you're still going to do the same thing. We're going to distribute each term of that first polynomial through every term of the second one. And then you put like terms together. A lot of times we call this foiling. Where a student taught in Albion, they called it Smiling Sam. When I was in high school, my teacher called it the claw. It's all doing the same thing. You're just taking each term of the first one and distributing it into each term of the second. So if we have two binomials here, so the 3x times the 5x, so the first there,
15x squared.
3x times the negative 3, the outsides.
Negative 9x.
So insides, the 4 times the 5x.
20x.
And then the last 4 times the minus 3.
Next one, easy.
So this is why my teacher called it the claw, because as this rolls around when you draw these in, it looks like it's a claw wrapping around there. So last thing we gotta do, put like terms together. There's only one x squared, so that one's good. We can write that. We have two x terms. When we put them together, what would we get?
11x.
And then our minus 12. So, questions with multiplying two binomials. So, and this was kind of the reason why my teacher called it the slick law. What's nice about the claw is it'll keep working for any amount. You're just going to take each term and you're going to draw it, go into each term there so you know what to multiply. And then when you do the second term, you go underneath here. But this will work for any amount. We're foiling it specifically for binomials, but it's the same kind of principle. So if we multiply this out, 2x and x squared make 2x and 4x. X squared. And 2x times 5. So we do the bottom, 3 times x squared. 3 times 4x. And 3 times 5. I know some people will write it so that it matches up below, so it's easier with adding them together, and that works too. But from here, we're going to put like terms together. So 2x to the third, plus we have 8x squareds and 3x squareds, so 11x squared. We have a 10x and a 12x, so 22x. And then our 15, and that's it. So, questions with this stuff. So, all this you should have done last year in Algebra 2. So, hopefully it's nothing new. But we do get into some special products here. So, some special ones where they start going through and figured out, hey, there's a pattern when we do ones like this. So, first we have our sum and difference of two terms. So, when they're opposite signs like that, when you multiply them, it's just going to be the first term squared minus the second term squared. So this is kind of like what we did with the rationalizing there. Because they're opposite signs, that's going to cancel the middles, so you just have the first ones and the last ones. When you square a binomial, you're going to get this term of the first term squared plus 2 times each of them times each other, plus the last term squared. And we have when we cube it, and that works the same thing when we square it, when it's minus. Only the middle term is going to go negative there, is the only difference. But when you cube them, you'll get this form of the first one cubed plus 3 times the first one squared times the second plus 3 times the first one times the second one squared times the last one cubed. And it just switches signs when you do the minus. And that is a typo there because this should be minus and this one should be minus. Not plus. So if you want to make that correction, that is my bad.
So could we just do it otherwise writing it twice?
Or you can just, multiply it all out just like normal. But this is the way that you can kind of shortcut some of that by using these forms. Now, when polynomials have multiple variables, you're still going to add the exponents of the certain variables there. So like when you're multiplying and stuff, you're still adding like terms variables. But when it comes to degrees, you're going to add all of the variables in that term. It doesn't matter what all the exponents, it doesn't matter what the variable is. So like for example, if we had 7x to the third, y to the fourth. So even though the biggest exponent for x is 3 and the biggest exponent for y is 4, it's not going to be to the fourth. You add them all together in the same term. So this would be a 7th degree, is what that's talking about there. Does that make sense? Any questions there? Okay. So if we get to multiplying here, same sort of a thing when we multiply it out. Like I said, you're going to just multiply the like terms. All right, and do the exponents with the like terms, I should say. So like here, x and 3x would make what?
3x squared.
But now when we do x times minus 5y,
Minus 5y.
Yeah, we're not going to put them together. We're going to keep them separate with different variables. So the 4y times the 3x
plus 12xy.
plus 12xy and 4y times the negative 5y.
Negative 21y.
So normally when we have a single variable, we do descending order. So when we have multiple variables, you're still going to do that. You just pick one variable to do. So if we want to stick with x, we would still write the x squareds first, then the x's, and then no x's on down. So 3x squared minus 5 and plus 12 would be a plus 7xy. And then the minus 20y squared. So it's still in descending order according to x in this case. And we could have done it with y as well. You can do either one when you get to that. Now we have a trinomial times a trinomial. So yeah, you can go through and just FOIL it all out like we normally do, where we're going to distribute each term to the next one. Or we can look at this as the beginning here is the same on both. So this is really a difference of, or a sum and difference of two binomials. If you want to look at it that way. So when you would do it, you would get the first one squared, so 7x plus 5 squared, minus the last one squared, 4y squared, if we follow that formula. So I'll show you the kind of the formula way, and then you can tell me later if you like it that way or if you want to do just normal multiplying. But I just want to show you another way here. So then if we go about it, well, if we square this, 7x and 7x will make 49x squared. 7x times 5 would be 35x, then we double it, so plus 70x. And then 5 times 5 would be plus 25. The back part minus 4 squared would be 16y squared. So if you use the special formulas, you could really do it in 2 steps versus going through and distributing, okay, 7x times 7x, 7x times 5, 7x times 4, and then going to the 5 and distributing it, then the 4 and distributing it, and then putting it all together.
So how did you get the 70x?
So the formula was when it's squared, I'll show you. So when it's squared, it's just double of the first term times the second term.
Oh.
So 7x times 5 would be 35x, and then you double it because you'd get it the two insides, inside and outside part, would double that up. But if you would go through and distribute it all out, you would get the same thing in the end too. So, any questions here? All right then, that will conclude the lesson.